All right, sweet geeks, thanks for coming out today. We're going to get started with our real presentation here in 5 minutes. But while everyone's getting their food, getting their lunch and such, we're going to have a hard-hitting technical interview. Right, that's what this is, right, Andrew? Yeah, that's it. All right, with Andrew and Ben. So here you go.
Thanks, Eric. Morning, everybody. It's morning somewhere. Hey, somebody call. Hey, how you doing? Nice to see you. Hey, I came to Sweetwater about a month ago, and a big part of the reason I came here was to get to know people in a real physical environment and get to meet some really cool people. And I'll tell you what, so far this place has exceeded my expectations. There's a lot of really awesome people here doing cool things. Cannot believe the welcome I got. It's been fantastic. And I got to tell you, one of my favorite things about working in software and IT over all these many years that I have been doing that is getting to know young people that come up as interns or, first job out of college. I love meeting those people and watching them turn from fresh-faced, kind of smart-mouth kids into senior leadership developers. It's a really cool process to see. And I get to meet our friend Ben Eager here during Launchpad last week. Say hi, Ben.
Hey, guys.
This is Ben Eager, starting out at Sweetwater this month. First job out of college, fresh-faced, ready to go. Got all the energy, isn't worn down by life yet. So I'm going to challenge our friend Ben here a little bit with a little game that I like to call, Are You Smarter Than a 56-Year-Old? We're going to test a little bit of Ben's knowledge. These young guys out of college, they're smart, they're educated, they know pretty much everything.
We'll see about
let's
that.
test that. What's that?
We'll see about that.
Yeah, we'll see about that. Let's see how true that is. One thing that you guys, the older folks, might know or might not know is that guys Ben's age, they don't know phone numbers because they don't have to remember phone numbers. You give them a phone number, they put it in their phone, and then they forget it. They never see it again. So what we're going to do is we're going to give Ben a little test. This is your first job. It's exciting to be in an awesome company like this. Ben, what is the phone number here at Sweetwater Sound if you were to dial it directly? What number would you call? That's question number 1 for you.
Okay. Well, seeing as I don't even know my own extension.
Just Google it.
That's a good suggestion.
Just-in-time learning.
Am I able to Google this answer?
No, you're not able to Google this answer. Can you tell us Sweetwater's phone number?
I think I'm 0 for 1.
He's 0 for 1. I will tell you because I wrote it down. It's actually on the back of the card, but that's too small for me to read because I'm old. That number is 260-432-8176.
Is that on a business card?
It's on a business card right here. It's on my business card.
Look, that's cheating. Come on, let's be real.
Oh, yeah, absolutely I'm cheating. But my point is we're going to get to question number 2, which is something that came up in Launchpad last week when we were watching some old videos of Sweetwater stuff. Now we're going to test Ben's memory a little bit. Because in 1979, if you wanted to call Sweetwater Sound, what number would you dial? Ben?
Oh, man.
Remember, in 1979.
In 1979. Oh, shoot. Is that the 219 number?
There you go.
Yeah.
Got it. Tell us what that area code was.
Shoot. I can't remember the rest of the number. I just remember in Launchpad you were like, 219. I remembered when everything was 219.
He's right. And he never realized that the area code in this area used to be, as many of us older guys know, 219, and you dialed 219 instead of 260. So I'm going to give you credit for that. Great job. Well done.
Sweet.
Another topic about that we had in Launchpad was the fact that if you call that number now from anywhere in the United States, it's just like calling next door, right? No big deal. Call that 260 number on your cell phone, connect right to them. In 1979, if you were from out of the area, let's say you were just across the state line in Ohio, that would cost you money. You'd have to pay to call that number, that 219-432-8176. Yes, I looked at it again to check. You would have to pay. So let's say you wanted to make a 15-minute phone call to a Sweetwater sales engineer from just across the state line in Ohio. What do you think that would cost for a 15-minute phone call from Ohio to Sweetwater Sound in 1979?
Okay, I actually remember someone in Launchpad making a comment that some of the rates were like 15 cents a minute for some, I can't remember what the circumstance was. So I'm doing math in my head, like 15 cents a minute. So you said 15.
15-minute phone call.
Oh my gosh, algebra. 15 times, it's like 225, right?
You're on the right track, but according to actual AT&T rates in 1979, a 15-minute phone call across a state boundary would have cost about $4.83, almost $5 to call a Sweetwater sales engineer and talk to him for 15 minutes. That's what our customers had to pay before we got a toll-free number here.
Wow.
But that's not the bad news. The bad news is that's in 1979 dollars. 2022 inflation-adjusted equivalent, it would have cost $30 to talk to a sales engineer to try to buy something for 15 minutes. Think about that, $30 you'd have to spend to try to buy something. And I like that, and I like telling you guys this because it's a good reminder of what we all are here to do. We are all here to make sure that our customers don't have to pay $30 to get great advice from sales engineers or purchase things from Sweetwater. And that's the reason that we've expanded our scope, and that's the reason that this company is as successful as it is, because of all the efforts of people like you in this room who made sure that nobody has to pay $30 just to buy something from us. So keep it up, thanks. We're gonna have a great presentation here. Thanks for playing along, Ben.
Yeah, no problem. Thanks, guys.
Have a great day, guys.
Thank you, Andrew and Ben. A couple quick announcements before we get into our presentation. We've got the B-Sides Fort Wayne Conference here tomorrow. It's going to be over in Conference Hall 1. The keynote session will be from the Chief Security Architect from Walmart. The rest of the sessions look really good as well. If you're interested in going, tickets are $25, but we have a couple, Sweetwater has a couple that we can give you. So if you're interested in going, message Kelly Smith on Slack or email or whatever. She'll get you those tickets. On June 6th, that is the WWDC announcement from Apple. We're going to be getting a conference room and kind of having a watch party for that. So if you want to watch the keynote, watch for an email or watch on Slack. We'll be following that and we'll be learning together there. Lastly, I had announced last month that we're going to be firing up a book club. That's going to be starting on June 2nd. We'll be reading The Pragmatic Programmer together. I'm going to order books this afternoon, so if you want to be in, if you want to take part in that, let me know real soon. All right, our presenter today is Guy Royse. Guy Royse is a developer advocate for Redis and just an incredible teacher. I have known Guy, we were talking about this beforehand,
Years and years.
Yeah, somewhere between 5 and 10 years, and I have learned so much from Guy. He is a frequent speaker on topics like graph databases, WebAssembly, probabilistic data structures, and if you want to know more about those, you can check him out on YouTube. I checked this morning. There's a bunch of his stuff available. So with that, Guy, take it away.
Thank you, MC Potter. I told you I was going to call you that. How's everyone doing today? I feel like there's way more hype than my talk can ever possibly live up to. See? There it is. Knock it off. Yeah. Oh, don't make me use my dad voice. So as Eric said, my name is Guy Royse. I'm a developer advocate at Redis. I hear tell some of you use Redis. Quick show of hands, who uses Redis? Who wants to use Redis? What do you use Redis for? Anyone? Caching, that's right. You probably use the get and set commands too, don't you? Yes. That's what most people use Redis for. Well, on this slide, there are 3 things that matter. One of them matters to my boss, one of them matters to me, and one of them matters to all y'all. The thing that matters to my boss is that Redis logo up there. He wants you to know that Redis, and I kind of want you to know, my options want you to know, that Redis is more than a cache. It does a lot of things. It's more than just storing strings and blobs and clobs. You can store all sorts of things in it. You can use it as a database, not just as a cache. And there's a bunch of modules that you can use to add to it to give it new capabilities. We're going to talk about 1, maybe 2 of those modules today, Redis Search and Redis JSON. The other thing that matters on this slide deck that matters to me is that Twitter username right there. I measure my worth as a human being based on how many followers I have on Twitter. So give me a follow. And feel free to @ me during the talk. I've got my phone safely in airplane mode. And the thing that you care about is github.com/Guy Royse. I'm going to have some code and slides and all this stuff. All of that is out there at that GitHub URL. So that's the part you care about, actually doing things. And I'm just going to humble brag. Oh, I'm not going to humble brag. I'm just going to straight out brag. Yes, I have guy.dev as a domain name. all it does is redirect to guyroyse.com. So in addition to being a developer advocate and measuring my sense of worth based off of how many Twitter followers I have, I'm also a big fan of Bigfoot. And there's just something compelling about this, this large, hairy hominid that's kind of wandering through the woods. It's just such a compelling story, and it's kind of, but everyone has trouble finding him. It's just something I've always liked. And, really, confession here, the reason that I'm kind of obsessed with Bigfoot is because Bigfoot was my father. This is the last photo I have of him. When I was a kid, he went out for milk and cigarettes, and then he just never came back. And so I've been trying to find him for years. It turns out he's hard to find. And so I've pursued a lot of strategies over the years in trying to find my dad. The first strategy I went to is I wanted to go look and do some research. Hit the stacks at the university and hit the really powerful press here. Dozens of witnesses seen Bigfoot roaming the wilds with a human child. That human child is me. That's me in the 80s with my dad running through the woods, somewhere near Cincinnati, near the Ohio River. We had stolen some food. I don't have that loincloth anymore, but that's probably for the best. But yeah, so I went and researched all these articles. I found all these stories about my dad, and some of them had me in them, but it sort of told me my past. It didn't help me find my dad. It just told me where he'd been. And it wasn't in a very useful format. I couldn't tie it together and, I'm not an investigative journalist. I can't, build this thing and, have the big board with all the strings connecting and saying, oh, this is the pattern my dad takes. And I can't do that. That's not what I do. I'm a developer. I don't do those sorts of things. And so I went to the people at Discovery Channel. And I love this photo. Have you ever watched this show? It's so great. It's got 3 true believers and a skeptic. Any guess who the skeptic is? I'll give you a clue. She has a look on her face that says, oh my God, what have I done with my career? They weren't able to help me find Bigfoot. But the guy on the right there, see if my little pointer thing works, that guy there, he is the president of an organization called the Bigfoot Field Researchers Organization, the BFRO. Founded in 1995, they are the only scientific research organization exploring the Bigfoot/Sasquatch mystery. And looking at this, clearly, this is a screenshot of their website. Clearly, it was built in 1995. In fact, I think Angel Fire might want their layouts back. But the thing that's really important here is that caught my attention was the comprehensive sightings database. Database? I could search a database. Maybe I could find some patterns. But when they said database, what they meant was lots of HTML files that are documents. Okay. Now, they're fine documents. They got 4,586 Bigfoot sightings in their database. But they're not easy to search. But unfortunately, the internet has everything. And this is Timothy Renner. He likes weird data. And he has gone through and screen scraped all these sites that have weird data on them. He's screen scraped the Haunted Places Index from the Shadowlands Haunted Places Index website and created a data set of haunted places. He's screen scraped UFO sightings from the New Fork, the National UFO Research Center. And he has screen scraped the BFRO's website and created a nice, convenient CSV file. Now, he did this for machine learning purposes. And so he's got some blog posts where he's talked about some of the stuff he's did. His jokes are hysterical. I'm going to share them. I've probably hyped them up too much now. But the UFO sightings data set, findings that he discovered. What do you think the most common day for a UFO sighting is? 4th of July. Is that a firework, Dad? No, son, that's clearly a UFO. You know where the most common location for UFO sightings are? In the sky, yes. Very good. Actually, I use the UFO data in my probabilistic data structures talk, and I count the most commonly used words in UFO sightings, and sky is in the top 10. So object, I think, is number 1. But no, it's within 50 miles of a US airbase. Right. The Bigfoot data, he was trying to find patterns in how you could find in where Bigfoot sightings were at. So one of the data elements we have is the location, the latitude and longitude. And so he used a machine learning clustering algorithm to find the natural groupings of this data. And then he's like, well, what do these groupings geographically correspond to? You know, they looked kind of arbitrary. And he overlaid a vegetation map of the United States and Canada on his data and realized that you could find Bigfoot in the woods. So I thought that'd be a good place to look for him. So the data is a lot of fun. He also mixed in some weather data. So this is what the data looks like. Here you've got an ID. This is the report number. So Bigfoot sighting 8086, right? This is just a lookup key. Got the date of the event. Got a title, which is sort of a quick little summary of what the event is. So here are a series of large human-like footprints are found on a farm near Wayne National Forest. That's in southeastern Ohio. And then the observed is sort of the eyewitness account. And, I saw Bigfoot, he was doing these things or whatever. One of my favorite things about this data is that the Bigfoot sightings have classifications. So you're probably familiar with close encounters of the first, second, and third kind sort of classification. Or maybe that's just me. Bigfoot sightings have Class A, Class B, and Class C. A Class A Bigfoot sighting is, I saw Bigfoot. Really straightforward. A Class B Bigfoot sighting is evidence of Bigfoot. So like maybe I heard some sounds or I found a footprint. Class C is someone told me they saw Bigfoot. Clearly the most reliable. Technically, all these would be Class C, wouldn't they? It's got the county and state where it took place. This took place in Noble County, Ohio. It's got the latitude and longitude. And then the location details is sort of a description of how to get there, right? Closest town was Harrietsville. Closest main road is State Route 145, right on the border of Noble and Washington counties. So it kind of gives you directions on how to get there. So that's the data that the BFRO gathers. Timothy has mixed in weather data as well. So you've got all the kind of weather data you would like and expect to see, precipitation, moon phase, everything. He was thinking maybe you could figure out, maybe if the weather was foggy, you'd be more likely to confuse a grizzly for Bigfoot or things like that. That's what he was thinking. And so he mixed that in as well. This is the data we have to play with. And this is the data I'm going to use to find my dad. Because I remember a particular day with my dad near Cincinnati, near the Ohio River. It was a hot day. It was a summer day. It was in that article. We had stolen some food from some campers and were running off and enjoying it. We left footprints everywhere. And so we're going to try and find my dad using, find that memory using Redis search. So I already sort of asked some questions about Redis. It's a cache. It's more than a cache. But if you're not familiar with Redis, I don't want to assume you all are, because lots of you have probably used it and lots of you probably haven't. I like to think of Redis as a, all those data structures you learned about in college? that you then never code because they all exist in your programming languages already, like hash tables or dictionaries if you're .NET people, and linked lists and arrays and all those sorts of things. Redis is just one of those, is a bunch of those in memory with a wire protocol in front of it. So you got a socket, and then you can interact with all these data structures remotely. It's networked memory. And I'm going to load all these things into Redis. We're going to search for them. And one of the questions I have to figure out is what kind of data structure do I want to use to store this Bigfoot data? A common thing to use in Redis is just use strings. So here we're setting strings in a Redis database. I've created keys here. So we say set Bigfoot sighting 8086 : classification. And so that's the key. And then the value is class B. So that sighting we looked at earlier, that's how we could store that data there as a key. And we can store the state as Ohio. Sorry, I live in Ohio, so all my examples are Ohio-centric. So. And then we can use get to get values. And so strings are just blobs of text or even binary data. They don't have to be text that you can get and set. It's just a block of memory. Redis also has lists. These are doubly linked lists of the variety that you learned about in college. We've got push and pop, so you can push things onto a list. Lots of times people will use lists in Redis as queues or some sort of like work queue. Hey, here's a list of things I need to do, and another thing I need to do, another thing I need to do. So you keep pushing to that list and then pop as you want to do work. So here I'm pushing a couple of new Bigfoot sightings onto a list, and then I'm popping off from the right of the list the next one I want to process. And so I could possibly use lists to store some of these Bigfoot sightings or to process them. Redis has sets. Sets are kind of cool. They are sets in the mathematical sense, so you can do unions and intersections and all sorts of operations against sets. And here I'm I've got a couple of sets named Bigfoot sightings by state Ohio, Bigfoot sightings by state Kentucky, and then I'm adding IDs for those Bigfoot sightings for those particular locations. And I'm using the set add command or the sad command. It's the saddest. It's the loneliest of all Redis commands. And the s is member, set is member, the sys member. Well, it can be used then to say, is this value in this set? So you can check a set to see if something's in it or not. And hashes, which is what I'm going to end up storing my data in. Hashes are dictionaries. So you've got a key in Redis, and then it's got several fields in it. So here I'm setting the Bigfoot sighting 8086 with a classification and then a value and the state. This is actually a lot like what I did with the string, except it's going into one key. You can think of that key as sort of a record. And then you can get values out of that hash. So that was Redis in 5 minutes. I'm going to represent my data as hashes because a hash is a good representation of a record. And so the set of all of my hashes in my Redis database will sort of act like all the records in my database. Each one's a key, and then there's multiple fields within it. So here we've got the Bigfoot sighting I showed you earlier, but using hset. So that's great. I've got all this data in Redis. I've got all these Bigfoot sightings in Redis. How do I use them to find anything? That's the next big problem. You don't want to just write things to a database. You need to read it from them. You read from that database often, usually much more than you write to it. Well, one way you can do it, this is the easiest way, is if you know the ID of your key, if you know the ID of your report, you can just make it part of your key. So here I'm using the hgetAll command, which gets all the keys, or all the values in a hash. And then I've got a namespace on my key name. So it's Bigfoot : sighting. So all of my Bigfoot sightings are going to start with Bigfoot : sighting : and then they're going to end with an ID. And so this is a really easy way to find things in Redis. Hey, I want to look up Bigfoot sighting 8086. Okay, construct your key, go get it. It's good if you're doing CRUD, right? If you want to just create these, read these, update them, delete them, you can easily find things that way. But if you don't know the ID, this isn't very helpful. And if I'm trying to search through the data to find a particular event in all of these Bigfoot sightings, this isn't going to help me solve that problem. So what can I do? Well, you can use sets. A nice pattern for indexing your data in Redis is to do it manually using sets. So the idea here is that you've got a set for each field you might want to search by and the value therein. So here we've got a set that is the Bigfoot sightings by state Ohio, and then it's got the IDs for all the Bigfoot sightings that are in Ohio. And then we could interrogate that set and say, give me all the sightings for Ohio. And then I could then go and get all of them. And then here I've got one for Bigfoot sightings by class B. And so you end up with 50 Bigfoot sightings by state. Ohio would be like Alaska through whatever, the West Virginia probably. Probably wouldn't be 50 of them because I don't think there's any Bigfoot sightings in Hawaii. So that seems unlikely. And then you have the 3 classifications. So you've got a lot of these sets, but you can store these and use these as indices. And then you can say, I want all the Bigfoot sightings in Ohio, or I want all the Class A. And here's how you do that. So you call the S members, set members. I'll give you all the members in a set. I call it SMembers. I like pronouncing all the Redis commands. My favorite, I was telling this to Eric on stage when we were doing the sound check. If you've got a list, there's a rpop lpush command. So you can pop from the right side of a list and push it to the left side of another list. And there's a blocking version of it, which is brpop lpush. And I always pronounce it as brpopplepush. And we actually did a little talk where we did it like as an HR puffin stuff kind of thing. So it was a lot of fun. But so SMembers. So SMembers will return all the members of that set. So that would give you all the IDs for Bigfoot sightings in Ohio. You can also do unions and intersections. So if you wanted to get all the Bigfoot sightings in Ohio and Kentucky, you could use the SUnion or the SunIon command. It's the one no one ever sees, right? But that's just, and you can pass in as many keys as you want here. So if you want to just do Ohio, Kentucky, and Indiana, then you could add another set there, and that would return all of those as one big thing. You can do intersections using Sinter. And so this is going to say, give me all the IDs, all the members of these 2 sets, all the IDs for Bigfoot sightings that are in Ohio and are Class B. So this is actually a fairly simple, reasonably powerful mechanism to index your data and find things in Redis. But it's got a few problems. And it's not just that John Mills is on my slide here. These indices are kind of a pain in the ass, right? You've got to manage them, right? So if I change a value in my hash, if this Bigfoot sighting 8086 is no longer in Ohio, it was wrong, so it's in Kentucky, and it wasn't evidence of Bigfoot, it wasn't a Class B, it's someone saw Bigfoot, it's Class A, well, I need to update my set. I need to remove that ID from Ohio, add it to Kentucky. I need to remove that ID from Class B and add it to Class A. So I've got 5 Redis commands here. So you got to manage these. And you get a lot of these, right? You can imagine, I'm using 2 fields, state and classification. But there's probably more fields than that than you want to search on. And so you can create a lot of indices. And so managing them is a big problem. The other thing is, managing them isn't atomic. You can make it atomic, but I could go in and update the set, and then someone else could come in and request all of the Bigfoot sightings in Ohio. Now they're going to get something that's going to clearly say Kentucky. And then I update it after the fact. Now you can solve this by using commands in Redis. You can use transactions using a multi-command. The multi-command is a mechanism for doing optimistic locking. but it's optimistic locking, and so sometimes it fails. So not only do I have to then wrap this all in transaction, but then I have to write code to make sure that if that transaction fails because something changed from underneath me, that I go do it again. And so this, for small cases, sets work great, but as you increase the scope of what you're doing, the complexity soon becomes problematic. And you can't do all the kinds of searches that you would want to do. You can do some of them, like Ohio and Kentucky. That's not hard. We just do S-union. But if we wanted to do Ohio and Kentucky and it's Class B, footprints. Well, we can do an intersection against the Class B index, but what do we do it against? We can't like nest these. I can't nest a union inside of an intersection. You could actually do the union first, store it in a temporary key, and then do an intersection on that temporary key, but now you've got to clean up that temporary key. And so this is kind of getting a little harder, getting a little more complex. My encounter with my dad was somewhere in Kentucky or Ohio near the river. It was, we left footprints everywhere, so that's Class B. But it was also a hot day. And so I want to find where the temperature is greater than 75 degrees Fahrenheit. How do I do that? How do I build a set that stores that? And it was near a river, near a creek. I probably should say crick, shouldn't I? But it was near a creek. How do I do that? How do I build an index for that? I want to search for a word in the text. And it was it was near Cincinnati. So how do I see if it was near Cincinnati? He asked rhetorically. Shockingly, the answer is Redis Search. So Redis Search is a module that you can add onto Redis. It extends the Redis's capabilities. It gives you all of this indexing I've been talking about and more. Just a sec, I gotta hydrate. And so it manages all these indexes for you. You update your hash, or you update a JSON document, and then it will update the index for you automatically. So you don't have to do any of that. And it does it atomically. It has full text search capabilities. So in addition to searching for where the state is Ohio or where the classification is Class B, I can search for keywords. So I can look for words like creek or river or Walmart. There are, by the way, 5 Bigfoot sightings in the data set that have the word Walmart in them. Because of course there is. By the way, there's one that has the word Amish in it. Yeah. And it also does aggregation, which I don't know if I'm going slower than I'd like to, and so we may not get to that. We'll see. But if we don't, we don't. But the aggregation lets you do group by kind of thing. So you can go through your data and say, well, count up all the Bigfoot sightings by state, or give me the average temperature by state, those sorts of things. Just like if in a SQL statement, you would do a select star from table, group by this field, and then sum this other stuff. It does those sorts of things. To create an index in Redis, we use the ft-create command. We give it a name. This is just our name for our index. I usually do whatever my prefix is for my keys. It's like Bigfoot sightings : 8086. Then this is Bigfoot sighting : index. That's my pattern. We tell it the data type we want to do it on. You can do that on hashes, and you can do it on JSON objects. Redis JSON is another module for Redis. It gives you a JSON data type, and so Redis Search knows how to look at those as well. We're just going to look at hashes today, but JSON is pretty cool. You can provide a prefix, which is all the keys in Redis that start with these with Bigfoot : sighting : that are hashes are what it'll pay attention to. This is optional. If you don't provide it, it will look at all hashes. That one just means I have one key. If I wanted to provide 2 keys, I could say prefix 2, Bigfoot sighting, and then like UFO sighting or something. And then you define your schema. The schema has what the field name is in the hash. It has a type for that field. There are 4, text, tag, numeric, and geo. And you can optionally make them sortable, so if you want to sort your results on that field. Once you've created your index, you can start using it to search. The simplest search is star. So you call FT search, give it the index name, give it a query. Strictly speaking, those quotes aren't necessary, but your queries almost invariably end up with spaces in them, and so it's a good habit. But this is just going to say, give me everything in the database. This is select star from users, where clue greater than 0. You can limit and to paginate your results. So this says, starting at page 0, at position 0, give me 3 records. I could say start at position 1,000 and give me 100. And then you can choose to return all of the fields, but if you actually specify a return, you can say, I just want to see the ID number and the state, the fields in this hash you want. So you can specify exactly what you want back. Your results are going to look something like this. You're going to get an array of arrays of arrays, which is kind of how Redis tends to do it. What clients do you all tend to use with Redis? Do you use node clients, or are you looking at the Stack Exchange? I'm guessing Stack Exchange, because I think, are you .NET Shop? What all technologies you people use? PHP Redis. What's that? PHP Redis. I'm sorry. Well, all these commands are available on most Redis clients, because most Redis clients do have a execute arbitrary Redis command, and you can totally do that with these. But your result you're going to get back is going to be the number of sightings, 4,586, and then the key name, and then the keys and the values, the fields and values. And you can actually set limit 0, 0, and say, don't give me any records back, and that will just give you the count. And if you say return 0 at the bottom, you'll just get the keys. So you can actually kind of pare this down for what you care about. I mentioned there were 4 types of fields: text, tag, numeric, and geo. Text fields are full text searchable fields. They're human readable text. It's the eyewitness account, the observed, the title. It allows us to do searches on data that are meant for humans. Tags are more like a tag cloud on a blog post. They're comma separated or pipe delimited. You can delimit them on whatever you want. Fields that contain like Class A, Class B, Class C. They also make really good IDs because they can have just one tag. Numeric is, well, they're numbers. And geo is a position, a latitude and longitude. So we can search by all of these things. If we want to search by text, well, here's the create that would create that. This is just a subset of the stuff I showed you earlier. So here we're indexing, in our schema, we're looking at title and observed. Title being the title of the Bigfoot sighting, observed being the details. To search keywords in this index, you just call FT search index, and then you pass in the word. So this will find all the Bigfoot sightings that have the word creek in any text field in it. And that's it. It's actually very easy. If you want to search for creek and river, just put both words in there. This will find any Bigfoot sighting that has the word creek and the word river. If you want to use the word creek and optionally river, you can put a little tilde in front of it. And it will actually score. It'll weight the ones with the word river in them higher. And so those will float to the top. Right. Pun not intended. You can do creek or river. Creek or river and stream. Creek or river, not stream. And you can specifically say, in a field, I want to look for text. So I want to look for the word creek in the title, and I want to look for the word river in the observed. So you can actually specify the fields. So a lot of capabilities here. If you set up your schema with weights, so here I'm weighting the title at 2 and the observed at 1, this means that when it comes to scoring the results and you search for things with the word that you're looking for, if you're looking for the word creek and it's in the title, that will score higher than if it's in the body. So you can do weighted full text search. It's full text search, so it understands stop words. Stop words are really common words that aren't useful to search on. So like these ones. They're all the words that we're using in English all the time. A, and, a, is, are. Words that if you search for them, everything's going to hit it all the time. So if you search for those, it ignores them. You can turn that off. And you can change the language and use different stop words. It also supports stemming. Stemming is the idea that if I search for the word give, you will find other words that are grammatically the same. They're grammatically similar enough that that's what you meant. So if you're searching for give, gave also makes sense. Gives also makes sense. Given and giving. It does plurals, looks for, past tense, all that kind of stuff. Many languages are supported for stemming. Obviously, I've only done the stuff in English. Allegedly, this works in Chinese. I have no idea how it works. I've been told there's an slightly unusual case where the Chinese stemming is a little different, but I just have to take. If that comes up, you'll learn about it. So this is great because this means that I can search for Bigfoot sightings that have the word creek in them. So let's do that. As the screen goes dark, it'll come back. There we go. So I've got here some code, and this is not very brilliant code, but it loads up a bunch of hashes. And I'm not going to go through this code in detail. I'm just going to run it. I'm just going to do npm run load hash. And that's just going to tear through my Bigfoot sightings data here, all 4,586 of my Bigfoot reports. And it's going to read that CSV file and load it into Redis. We'll go ahead and load the JSON in too. And then I got another little thing to index it, index the hashes. This will call create index. So if we look at create index hash, all I'm really doing here is I'm calling ft.create. This is in node Redis. And then I'm giving it, the hash index is a config option. It's just a string. And then here's all my information saying, okay, I got the ID, which is a tag, it's sortable. I got the title, it's got a weight of 2. Like observed is a text. Latitude and longitude are both numeric. Location is a geo, so it's searchable, that kind of stuff. And so all this code's out on GitHub. So I've got them all loaded now. And if we go over here and refresh this, we can see that I've now got keys here. This tool is called Redis Insight, which you can download it. I got a link at the end, but I think it's redis.com/RedisInsight or something like that. It's just a GUI for Redis, and so I can click on like one of these hashes, and it'll bring up the fields here. So here, this particular Bigfoot sighting is a hash 1445. Is in South Dakota. There's directions. Observed when I was in senior high school, 1986. I was staying overnight at a friend, anyhow. And it doesn't have a title for some reason. If you're using JSON, you can store these as JSON as well, and you can see that it's actually coming back as a JSON document. So French hiker observes 2 Bigfoot. Wouldn't that be big feet? In Olympic National Park on January the 4th, 2001. And then it tells this great, I'm sure what is a great story. I've never read this one before. There are 4,586 of them, and the order they show up in just seems to be random. So, but I want to find ones that have the word creek in them. So I'm going to go over here to my little Redis terminal. Is that font big enough, by the way? Okay. I can do ft.search. And I want, here, let's just copy this one. This is the Walmart one. There we go. We got 5 Bigfoot sightings that happened in Walmart. Got lots of data here. Kansas, Virginia, Michigan, North Carolina, and Washington. Thank God it wasn't one in Indiana. And we can go ahead and grab one of these. Let's copy this key here, and we'll just go back over to here. And one of the things I like about this is I can put in a key name and it searches for it. And then I can click on that and I can see the text. So this is in Kansas. And this was approximately 5 miles east of Pratt Walmart on the south side of the road, crossing the dirt road. So it was near a Walmart. We go here. The other one that's kind of fun to search for, aside from Creek, is Amish. We've got one. And if we go over here and let's get the JSON version of this instead. There we go. Click on that. Memory told of a mid-afternoon encounter along the Flat Rock River. I actually have read this one. It involves a bunch of guys hanging out by a creek somewhere near Amish country, it tells a story. They're throwing pop cans in the creek and letting them float down and shooting them with their .22, as one does in rural. Where does this take place? This might be Indiana. Where is it at here? Yeah, it's in Decatur. Yeah. So it has the ring of truth to it. But anyhow, let's go ahead and search for Creek, because that's how I'm going to find my dad. So 827 of the Bigfoot sightings have the word Creek in them. That's not narrowing it down very well, but it's better than 4,586. Cool. Get my slides back here. So I found all the Bigfoot sightings that have the word Creek in them. Let's look at tags. Tags are these sort of comma-separated fields. I mostly use them as IDs. I don't tend to use them as lists, but you can. Here I'm taking the state, which is a great example of a tag field, because it's the whole string. You're matching the whole string for a value, and the classification. To search on tags, you use curly braces. So you reference the field name, @state:, and then in curly braces, you put the state. So this would find all the Bigfoot sightings that are tagged with Ohio, where the state is equal to Ohio. Or more accurately, the state has a string that is comma and limited, and one of those values is Ohio. In my data, they're all just a single value. You can do an OR search. I want Ohio or Kentucky. Spaces are fine. So it doesn't care about spaces in the middle of it. So this will look for West Virginia. But there's a gotcha. Sometimes part of your word will be a stop word. So like in Class A is a stop word. So the query engine filters it out. So if you escape that space with a double backslash, then it'll treat it as one string and it won't trigger the stop words. So if you have spaces, they will work, but you generally want to escape them. It's good practice. So that finds classifications that are Class A. You can also do an AND search where it's tagged with Class A and Class B. But in order to do that, you have to just do it twice. So here I'm saying @classification is Class A, space, @classification is Class B. So you can do ANDs and OR searches. This is how you do the AND search. And so if I want to build up my query, I can add @state, Ohio or Kentucky, and @classification, Class B. And we can go ahead and narrow this down a little bit. The transition from modes on my MacBook is always a little slow here, but we want to look for the word Creek. @state contains Ohio or Kentucky, and did I call it classification or class? Classification. And it needs to be class B. And I'm going to break my very own rule that I just said you should do. But we got to put all that in quotes. There we go. That takes it down to 33. This is a much more manageable number. We're narrowing in. Numbers. To search on numbers, you use square brackets, and you provide a low bound and a high bound, a lower bound and an upper bound. So here we got temperature high between 60 and 75, inclusive. Here, if we want to say temperature 60 and up, we can use a positive infinity, we can use a negative infinity, and we can say all the numbers. And if you want to make them exclusive, you can use a little parenthesis there. So that last one would find high temperatures that are above 60 but not equal to 60, and less than 75 but not equal to 75. And so numbers are fairly easy to query too. And so if I want to do a high temperature search for 75 and higher, that hot day with my dad, I can do it like that. I'm going to skip the demo on that one and just keep moving forward because I think I've got like 10 minutes left. You all probably have meetings you need to get to or families. I'm glad you know where your father's at. I'm still trying to find him. I feel like using the SAD command. Geolocation is a little different. You just define it as a geofield, but the value in the field has to be in a specific format. And that format needs to be longitude first, and then latitude second. It needs to be a string, and it just needs to then be that value. Negative numbers are west, positive numbers are east, negative numbers are south, positive numbers are north. And so this is the coordinates for Cincinnati. And if you have a string that's in that format, then you can do a geo search on it. It's worth noting that lots of times people get a overly precise number in here, and it's like 14 digits of precision in your geolocation on each one. Redis search will totally vomit on that. And everyone's like, but I need it. It's like, because you need to know whether the electron is on the right or left side of the atom. You don't need that much precision. 4 is plenty. To actually do a geo search, use square brackets again. But instead of an upper and a lower range, you provide the longitude first again. This is an easy one to get wrong. The latitude second, a distance, a radius that you want to search in, and then units for that radius. So this would find all the Bigfoot sightings within 50 miles of that location. That would find them within 100 feet. 25 meters, and 10 kilometers. So that's GeoSearch. So this actually gets me all the criteria to find my dad. So let's do that. Okay, so this is putting that all together. So let's do that real quick. And then I'm going to skip the aggregation bit because I've run out of time. There we go. And I have conveniently provided that index, that search already. So this should be, I don't care about the limits. Give me everything. Okay. So we're going to search a Bigfoot sighting index. Creek, state is Ohio, Kentucky, class B. Temperature is high between 75 and infinity. Location is here. Am I missing anything? I think that's everything. Oops. Bigfoot sightings hash index. And it's classification, not class. There we go. Now I've got it down to 2. I feel like I'm missing one of the values. I thought I got it down to 1, but regardless, let's take a look at them. I don't remember this one. It's in Preble County, so that sounds plausible. Family going fishing finds a large, strange footprint in a sandbar. I seem to recall stepping in a sandbar. Well, anyhow, so hang on. There we go. So I was able to narrow it down from 4,586 Bigfoot sightings to 2 that I need to look at. Totally manageable. So that was my demo. I've got a bunch on, this is a handy little slide. This is just if you use SQL, this is some SQL equivalents for Redis search commands. And I'm going to skip through a few of these slides here to the end here because I'm almost out of time. Aggregation is a thing. Slides, moving through slides. You can do a series of filters to narrow your data down. You can do groupings. You can create dynamic fields. So like up here I've got, you do transforms. So here I'm creating high temperature. I'm calling it high F, not high AF. Here I'm doing high C, so I'm doing a calculation to convert that Fahrenheit temperature to Celsius, right? So that's what you can do with transforms. You can do some grouping. So if I want to get the average temperature of Bigfoot sightings by state, you can sort the results. So aggregation lets you do lots of groupings of the data. It's exactly what you call it. You all do it through the ft aggregate command. I've got some fun queries to put this all together here. I just kind of want to show the results of these. The first query, what it does is it generates the number of Bigfoot sightings per month from the entire data set. In this case, from 1970 forward. This is fun because you see that Bigfoot hibernates because you get the low spots in the winter. This tells us what month Bigfoot sightings happen in, which further confirms that Bigfoot hibernates because he's not out in February and March. It's totally coincidental that humans are also not out in February and March. And this tells us what day of the week Bigfoot sightings tend to happen on. And this tells me this is humans, right? Because Saturday is the #1 day. How many of you like to go camping? A few of you? So, you go out on a Friday after work, maybe tonight, and then you get there, you set up, it's pretty much dark, you eat, you go to sleep, then you spend all day Saturday in the woods. Then Sunday morning you pack up and leave. This is the most common day for a Bigfoot sighting because it's the most common day for humans to be in the woods. So, not going to demo that. Some resources to go check out, but really all you need is this QR code here. This will take you to my GitHub repo with the slides, the code, and everything. You can trust it. It will never give you up, nor will it let you down. Run around and take you to some other site. I'm happy to entertain questions, but I know you all have things to do too, so I can just take those afterwards informally. Is that okay? You just come up and talk to me like a human. So we've got a Discord server. If you have questions, I'm always on there. We got free classes. I think there's even one on Redis Search. And Redis Cloud is free to try. That's the easiest way to start playing with this is use a Redis Cloud account. I'm Guy Royse. Thanks.